Hello everyone, this is Dr. Daya Sagar Chowdary, Senapati, Assistant Professor, Department of Electronics and Communication Engineering, Aditya University-Surampalem. Today our topic is Programmable Array Logic. Simply we call this one as a PAL. Coming to the learning outcome, at the end of the lecture, student will be able to understand the architecture and operation of Programmable Array Logic. So we call this one as a PAL. Design and implement Boolean functions using PAL and evaluate its advantages and limitations in practical digital system applications. So coming to PAL, PAL is a programmable logic device that has programmable AND array and fixed OR array. So here if we observe this figure, so it contains programmable AND arrays and at the same time fixed OR arrays. So depending on this particular block diagram only, we can conclude that AND gate contains the programmable and OR gate are fixed. So here we can give n number of inputs and we can expect m number of outputs. So in between, some outputs of this particular AND gate array is given to the inputs of the OR gate array. That means AND gate is programmable here and OR gates are fixed here. And the advantage of PAL is that can generate only the required product terms of Boolean function instead of generating all the min terms by using programmable AND gates. Now here in a programmable array logic PAL, the inputs to the AND gate are programmable. Each AND gate can receive both the true and complemented forms of the input variables. By programming the required connections, only the desired product terms can be generated. The OR gates in a PAL are not programmable and each OR gate has a fixed number of inputs. The selected product terms from the AND array are connected to these OR gates to produce the final outputs. Therefore, the outputs of a PAL are expressed in sum of products, that is SOP form. And so while solving any problem, so these are the steps we have to follow. Derive the truth table for the combinational circuit. If a question contains any equations or expressions, we have to derive the truth table for that particular expressions. That mostly the expression is nothing but the Boolean expression. So we can solve with the truth table for the combinational circuit and reduce the minimize using K-map. So mostly K-maps here we are using for optimize the circuit or reducing the equation or expression. And draw the PAL program table. So here we have to draw one table. So it indicates the complete PAL content. So according to that it contains the literals, that means variables, everything is there, and the outputs also it will show. So that is why we can form one table. So PAL program table consists of 3 columns. Again it contains 3 columns. The first one gives the product term, number in the SOPs, and second column gives the required path between the inputs and outputs. Third term gives the OR gate outputs from the PAL. OR links not fusible. So here OR gates are simply we are saying those are fixed. And implement the logic using PAL. Some problems we can solve with the help of this particular equations and expressions. So here we can take one example, that is implement the following Boolean functions using PAL. So here the equation, there are 2 equations. It contains A is equal to xy plus xz bar and B is equal to xy bar plus yz bar. So here if we observe the figure, this is the figure. So it contains the 3 inputs. So we can simply find 3 inputs, that is x comma y comma z. Here the first term contains x and y and the third term contains the z bar, means z. So we can take x bar, y bar and z bar. So that is why to each input contains the true and the complement. So this is the true line and this is the complement line for the x, and this is the true line and complement for the y, this is the true line and complement for the z. So the 2 given Boolean functions are in sum of products, SOP form. Each function contains 2 product terms. So because here each function means here A and B are that contains 2 product forms, and therefore a total of 4 programmable AND gates are required to generate these product terms. Since there are 2 output functions, 2 fixed OR gates are needed to combine the corresponding product terms. That means each SOP form, that means each 2 AND gates. So in order to realize that XY with the help of this AND gate, and in order to realize that XZ bar, we have to use this AND gate, and for these 2 products, so each that one output we can get. So that means for these 2 products we can use one OR gate. So likewise we can also use this XY bar, this is the B term, and YZ bar, this is also the B term. So this is also one of the SOP form, and we can get the B term here by summing up. That means by using one OR gate here we can get the B term. That means we can get the final A and B term by simplifying these 2 expressions with the help of this particular circuit. Thus, the PAL configuration uses 4 programmable AND gates and 2 fixed OR gates to produce the required output. So simply we can use this circuit. Now here the programmable AND array. So here programmable AND array means here we can observe the cross marks. Cross marks means that is programmable. That means the inputs of the AND gates are that contains the cross mark. Cross mark is nothing but the programmable, and if we observe that dots for the inputs of this OR gate, that means these dots are fixed. So simply we are fixing these inputs for this particular OR gate and these inputs for this particular OR gate. These all inputs are fixed. But here while observing this cross marks for these are the inputs for these AND gates, all cross marks are the programmable. That is why the AND gates can access both the true and complemented form of the input variables by programming only the required literals, and each AND gate generates a specific product term. The X symbol indicates programmable connections. So these are the programmables and these dots are fixed. And fixed OR array, the OR gates have fixed inputs and the required product terms from the AND array are connected to the inputs of each OR gate to produce the desired Boolean function. So that symbol dot, we can use the dot symbol, represents fixed connections. And here the example 2 that contains again 2 terms. So each 2 term means here X and Y, 2 expressions that contains 2 terms. Here AB plus AC bar, these 2 terms belongs to X, and AB bar, BC bar, these 2 terms that are belongs to Y. So again, so this is the table we have to construct. This is the PAL table we have to construct. So here first column indicates the product term. So each product term we have to place it here. That means, so each term AB, so first AB we have to place, and AC bar, so AC bar, so these 2 are indicated in blue, contains, that means these are under X term. So and AB bar, so AB bar belongs to Y, and the BC bar belongs to Y. Again these 2 terms are that are represented in black, so that belongs to Y expression. Now so AB, so we have to use these are the inputs, we have to use the inputs. So the each term, all these 2 terms contains A, B, C literals. Now we have to represent the input terms A, B, C. Now A, B, C, again we have to check the term, that is AB. So A, here B. So if the A term is there, we have to represent it with 1, and here B term, B is also 1, so here this is not 0, this is 1. Okay, and here A is there and C bar is there, but here if we observe in the first term there is no C term. So there is no C term means we have to give dash mark here, and if A is there, so we have to place 1 here, and C bar is there, that means C bar is nothing but 0. But here there is no B term, that means again we have to represent it with dash. So likewise for these 2 terms, the expression is X is equal to AB plus AC bar, that means this is the output. So PAL table contains the product terms, the inputs and the outputs. This table, the 3 columns, these are the main used we have to use in PALs. And again for Y term, these 2 terms are there. Again inputs A, B, C. So here the term is A, B bar. A is in 1 form, but B is in 0 form. That means B bar. B bar means 0, and there is no C term. That is why we have to place dash here. Again, there is no A term in this term, product term. That is why dash, and B is there. B is in 1 form. That is true. And C bar is, that means it is in complement. So C bar means 0. So again, Y term we have to place here. So finally, we will get the output. These two terms are the outputs, and we can construct the circuit with the help of this particular products. So here, if we observe X and Y are the outputs, and whatever the SOP forms, these 4 are the terms. So that means that first OR gate contains 2 inputs. These are the 2 fixed inputs, and next AB bar and BC bar, these are the 2 inputs for this particular Y output. So according to AB, so these cross marks indicates the fuses. That means these AND gates are the AND gate contains the inputs that are programmable. But here only dot representation is there. That means these are the fixed OR gate representation. So according to the Boolean algebra, we can construct this circuit. Now coming to the example 3. So this example 3 contains 1, 2, 3, 4 equations. So each equation, that means here the W, X, Y, Z. So again, so it starts from, if we observe, it starts from 0 and ends with 15. That means totally we can consider 0 to 15. So in order to resolve this 0 to 15, we need A, B, C, D, 4 literals. That means 4 variables. So that is why already the question contains A, B, C, D are the inputs. Now we have to solve these equations, because with the help of K-maps we can solve this equation. To simplify this equation, we will get the what we call that optimized equations and optimized circuit. So now with the help of K-map, so if we observe 2, 12, 13 are the terms. Here 2 in place of 2 we have to place 1, in place of 12 we have to place 1, in place of 13 we have to place 1, and by solving with the help of K-map, that means we have to group these 2, the 12 and 13, and this single one, there is no grouping here, only that is the singular, and we have to give the equation, and the simplified equation is A, B, C bar plus A bar, B bar, C, D bar. So this is the final equation, optimized equation for W, that means simplified equation. And likewise we have to construct the, that means the K maps for all the X, Y, Z terms. So here this is for X, and this is for Y, and this is for Z. So Y we will get like this: A bar B plus CD plus B bar D bar, and X A plus B C D, and Z A B C bar plus A bar B bar C D plus A C bar D bar plus A bar B bar C bar D. If we observe, so the first 2 terms, it is just looking like the W. That means again we can replace the first 2 terms with the W plus A C bar D bar plus A bar B bar C bar D. So these 2 terms are, we can place as it is, but here these first 2 terms are replaced with W. So we can construct with the help of the output of the W, also we can place it as the input, and we can construct the circuit. So that is the advantage of the PAL. So here again we have to construct the table. So PAL table, so the first term contains the product terms, and second the input terms, and third the output terms. So here we already discussed it. So W is also one of the input now. So now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So here it is following the order. That means we know that PLA, PAL, PROMs are predefined hardware. So we can implement our whatever required equations we have to program on that particular circuits. So that is why these are fixed. That means 1, 2, 3 and 4, 5, 6. Likewise we have to take this product terms, and here the first expression. So if we observe the first expression A, B, C bar. So A, B, C bar means A is in 1 form, B is in 1 form, and C bar means that is 0 form. So Z is in bar, that is why 0, and there is no D term, so that is why this is dash, and there is no W, so that is why we have to place this W a dash. So finally my output is W is equal to A B C bar plus A bar, B bar, C, D bar. So likewise we have to use the second term and third term. Third term is all dashes because it contains only two terms, because we have to normalize all these products, that is why three terms we have to use. And finally, because the third one contains three terms, here also three terms, but here first 1 and 2 contains only two terms. That is why in order to maintain the uniformity, that is why we used this as a three terms, and this is a first term, and second term as a three term. Now if we construct the whatever the circuit, so again inputs are A, B, C, D, and W is also one input here, because W is only input for Z. The last term, the Z, the output Z takes the input W also, because W contains two terms. Those two terms already repeated in the Z term. That is why again here the output, that W is the output and is again used for this W bar in the input. Again the W bar is given in this particular, so the W is used again in this particular Z. So here the W is applied in the output of the Z. That means W is a output, but it acts as an input for Z. So likewise we are using. And finally X and Y, there is no change. That means we can use the terms so as it is, whatever the required A plus B C D. So according to the A plus B C D, we can simply take the output as a X, and A bar B plus C D plus B bar D bar as a Y. So that means that is the Y output, and these are the inputs, and finally we will get the Z. So finally we can conclude that according to this structure only the AND gates are programmable. That is why we are using all the cross marks inside input at the input of the AND gates, and only dots. Dot means here the OR gate inputs are fixed. If we observe, all the inputs of the OR gates are, or the outputs of the AND gates are directly connected to the OR gates. That means we are fixing the OR gates inputs. So that is why PLA is inputs are programmable AND gates and fixed OR gates. And coming to the advantages of PAL, so high speed operation due to fixed OR array and programmable AND array, and these are simpler design when compared to PLA, and cost effective for medium scale logic designs, and reduced propagation delay because of fewer programmable connections. Only AND gates are programmable, that is why fewer programmable connections. Easy customization for specific logic functions. In example 3, that we can construct easily with the help of that PAL. So coming to the disadvantages, limited flexibility, so compared to PLA. So again PLA contains both AND gate and OR gate are programmable, but here PAL contains only AND gate are programmable. So OR is fixed. And restricted number of product terms, limiting complex logic realization, not suitable for very large or highly complex logic circuits or designs, and reprogramming is limited in older PAL devices, that is fused based. And coming to the application part, implementation of combinational logic circuits. So we can easily implement combinational logic circuits, can be implemented on PALs. Address decoding in microprocessor systems, control logic design in digital systems, state machine implementation, and replacement for multiple SSI, MSI logic ICs. In ICs also we can use this PAL concept. Used in embedded and industrial control systems. So mostly this is for control system part, we can use the PALs in the particular industrial purpose. And coming to the summary, programmable array logic, we simply call PAL, is a programmable logic device featuring a programmable AND array and a fixed OR array, enabling efficient implementation of Boolean functions. It offers faster operation and simpler design compared to PLA, making it suitable for medium complexity digital logic applications. Thank you.